Hello, Algebra 2 people. All right, so now we're on to 3-3, completing the square. And I realize you did this in Algebra 1, but it's been a while, so let's review the process. We're going to start off with the second half of completing the square, which is after you've completed your square, you solve the equation by using the square root method. And this is something we talked about in the last section. So when you only have one squared term, in other words, there's no other x value, or you already have a perfect square, sometimes they're going to already set that up for you, then you want to solve by square root method, which I'm just going to call square root method, okay, which means you isolate the squared term and then you take the square root of both sides, don't forget to do the plus or minus, and then you solve for x, or whatever the variable is, okay? So I'm going to kind of, since we've talked about some of our solving techniques, show you that there is more than one way to solve things. So don't always think just because we go over one method, that's the only method. So this first example, I'm actually going to do it two ways. Notice we actually have a difference of squares. This is like a squared and this is like b squared. When you have a difference of squares, you can factor it into the square root of x, the square root of the last term, and then remember you put in a plus or a minus because there is no middle term. It got added and subtracted away, and then we can see the answer will be plus or minus 5. But you can also do this the square root method, where you isolate the squared term. So we move 25, add 25 to the other side. We're going to take the square root of both sides, and then we have x equals plus or minus the square root of 25, which is 5. So you have options. It looks like the square root method is actually a little bit easier, but it is a difference of squares as well. This next example, what you want to notice is this last term is 7 squared, and the middle term is 2 times 7. So that's a good indication, that is the indication that what you have here is a perfect square. So if I were to factor it, and let's say you didn't see it right away, so we go, okay, here's a times c, here is the middle term, what times what is 49 but adds up to a negative 14, that would be negative 7 and a negative 7. That tells me this is, since these are the same number, this factors into x minus 7 squared equals 64. So whenever you see a perfect square in that last term, it's worthwhile to check to see if that is already a perfect square. So we're ready now to just take the square root of both sides, and now we can solve. So x minus 7 equals, since this is a perfect square, I'm going to write it as a positive 8, and we have x minus 7 equals a negative 8, and then we have to solve for each. So adding 7, we get x equals 15. Adding 7, we get x equals a negative 1. And those would be your two answers. Okay, so that would be the square root method, which comes up when you are completing the square. So completing the square, first off, a has to equal 1. If it's not 1, you would have to factor it out, all right? It's best used when then your b value is even. That's a little bit easier, okay? And for the most part, we do this when your quadratic is not factorable. So these are the conditions when I would use completing the square. And then in terms of the goal, you're trying to create a perfect square. X plus c squared equals a number where you then take the square root of both sides. All right, so let's go. I have the process kind of mapped out here for you. So let's go through this. So here's your original equation. the first thing you want to do here is isolate the x's on one side. So I do a little more than just isolate the x because I am going to be adding something to both sides. So I'm going to subtract 2 from both sides. So I have a -2, and whatever you do to one side, you have to do to the other. All right, so I've isolated my x's. Now because we're trying to create a perfect square, that means the same number times the same number gives me that last term, but when added to itself gives you 6. So what we always do is we take half that middle term and we square it, because 3 plus 3 is 6, so 3 times 3 is 9. So I've added something to both sides. Now that allows us, so that was the second step, now we can factor this. Now the nice thing about factoring a perfect square is you know it's going to be a perfect square. On the other side, 9 minus 2 is 7. So x squared plus 6x plus 3 is going to factor into x plus whatever's in this parenthesis. Half of 6, that's always what goes here. So that'll be 3, because 3 times 3 is 9, 3 plus 3 is 6. Now we do the square root method. So we take the square root of both sides. There's a plus or minus here. So we have x plus 3 equals plus or minus rad 7. And the last step is to isolate your x. So we subtract 3 from both sides. -3 plus or minus rad 7. And we've now solved the quadratic by completing the square. So why don't you actually pause this video for a second and walk through the steps on your own, and then when you turn this back on, I will also then walk you through again in case you got stuck somewhere. All right? So again, first step is isolate your x terms, and I always leave a blank. So we're subtracting 30 from both sides. And then what we're going to do is take half the middle term, so half of a -12 squared. Half of -12 is -6 squared is going to be 36. And so now I've created a perfect square. And so 36 minus 30 is 6. And this is going to be x, whatever's in here. So half of a -12 is -6, because 6 times 6 is 36. -6 plus a -6 is a -12. We're ready to take the square root of both sides, and then we can simplify. So x minus 6 equals plus or minus rad 6, and then we just add 6 to both sides. So 6 plus or minus rad 6. If this radical could be simplified, you need to simplify it. If it's a perfect square, then you're going to actually find the two answers. It's what I call take the high road, take the low road. 6 plus whatever that number is, 6 minus whatever that number is. But so far, we've just had radicals there. Now, the last thing that they're going to ask you to do is just find the value that makes a perfect square. So what that involves is step 2. Which means you will always take half of the middle term and square it, and that will equal that last value to make a perfect square. So on these ones, we may give you odd numbers because you're just doing the one process, and this is the kind of thing they ask you on the SATs, because they can't actually check the whole process of completing the square, but they can see that you know that first step. So here's my first example. Here's my b term. So what we're going to do is we're going to take half of the -16 and square it. Now remember, when you square something, it all goes positive. So it's really half of -16 is a -8. -8 squared is 64. So C will equal 64. So what we have here is x squared minus 16x plus 64. And if you had to keep going to just show what would it factor into, this would be x minus 8 squared. You always pull whatever's inside the parentheses there. Okay, but the c value was 64. Then lastly, here we have a nice odd number, but that's okay. So half of 7 squared. Realize you can write this as 7 over 2, and we're going to square it. 7 over 2 squared. So you square the top, and you square the bottom, and that's going to be our c value. That would make this into a perfect square. And just to show you how that would look if we had to then factor it, so this would be plus 49/4. Remember, I told you these are really friendly to factor, even if it's ugly like that, because you just pull whatever's on the inside of the parentheses, x plus 7/2. And now the squared goes on the outside because you created a perfect square. All right, and that is it for completing the square.